Right now, wherever you are breathing without thinking about it. Take a breath, hold it. Somewhere around 30 seconds, maybe a little more, you're going to feel it. A tightness in your chest, a pressure climbing up your throat, a voice inside your body screaming at you to let go. Most people would tell you that voice is your body running out of air. It isn't. That is the first strange thing about being underwater. The urge to breathe has almost nothing to do with oxygen. The panic you feel is your body reacting to a completely different gas. And once you understand why, the whole story of how long a human can survive beneath the surface stops being a story about lungs. It becomes a story about a hidden switch buried deep in your biology, one you share with seals and dolphins and whales, one that most people will live their entire lives without ever knowing they have. So, how long can you actually stay under? The answer depends on a single question. Are you holding your breath or are you breathing down there? Let's start with nothing. No tank, no tube, just you and one lungful of air. If you're an average person who has never trained a day in your life, the honest number is humbling. Most people tap out before they reach a single minute. 90 seconds feels like an eternity. 2 minutes feels impossible. And here is the part that should bother you: your lungs at that moment are not empty. Scientists estimate that the oxygen sitting in your lungs and blood could keep you alive for roughly 4 minutes. So, why does your body force you to breathe when more than half your fuel is still in the tank? Because your body isn't measuring oxygen at all, it's measuring carbon dioxide. Every second you hold your breath, your cells keep working and they keep producing carbon dioxide, the waste gas you normally exhale. That gas builds up in your blood and turns it slightly acidic. Tiny sensors in your brain and in your arteries, called chemoreceptors, detect that shift and sound an alarm. That burning, that desperate need to inhale is not the feeling of running out of oxygen. It is the feeling of carbon dioxide piling up with nowhere to go. Think about what that means. Your body would rather panic far too early than risk waiting 1 second too long. It is a smoke detector that screams the moment it smells toast. Annoying, overcautious, and it has kept your species alive for a very long time. Now, here is where it gets dangerous. If the alarm is triggered by carbon dioxide, what happens if you get rid of the carbon dioxide first? That is exactly what some people try. They breathe hard and fast before going under, hyperventilating, flushing the carbon dioxide out of their blood. And it works in the worst possible way. The alarm goes quiet. The urge to breathe disappears. But the oxygen is still draining second by second, and now there is nothing left to warn you. You feel calm, you feel fine, and then, with no dizziness and no struggle, you simply switch off. Divers have a name for it: shallow water blackout. It comes with no warning and no mercy, and it drowns people every single year. Strong swimmers, confident swimmers, people who thought they were being clever in a backyard pool. This is why no one should ever push their breath holding alone in water. The thing that kills you is the absence of a feeling. So that is untrained you. A minute, maybe two, guarded by an alarm that lies about what it is measuring. Now let's meet the people who taught themselves to ignore it. Freedivers are athletes who dive on a single breath. No equipment, sometimes hundreds of feet down into the blue. And through years of training, they learn to do something that sounds almost impossible. They learn to sit calmly inside the panic. They don't remove the alarm. They raise their tolerance for it. They stay perfectly still. They quiet their minds. And they keep going, long past the point where you or I would have clawed desperately for the surface. A trained free diver can hold their breath for 3, 4, even 6 minutes without much trouble at all. But the true records live in a different universe. The longest breath hold ever verified without any tricks, no pure oxygen, just ordinary air, belongs to French freediver Stéphane Mifsud. 11 minutes and 35 seconds. That record has stood since 2009. Read that again. 11 minutes on one breath of the same air you are breathing right now. And if you allow one trick, breathing pure oxygen beforehand, to flood the body with reserves, the number becomes almost unbelievable. In June of 2025, Croatian diver Vidomir Maricic stayed underwater holding his breath for 29 minutes and 3 seconds, longer than most television episodes, longer than you have been watching this video. How is that even physically possible? Because the moment your face hits cold water, your body does something it never told you about. It flips a switch. Scientists call it the mammalian dive reflex, and it is one of the strangest pieces of machinery you carry. The instant cold water touches your face, your heart rate drops, sometimes by 20%, sometimes by 50. Your blood vessels in your arms and legs clamp down, squeezing blood away from your limbs and rerouting it toward your heart and your brain, the two organs that cannot afford to lose oxygen. Your body, without asking your permission, decides which parts of you matter most. This is not a skill freedivers invent. It is a reflex you were born with. It is the same response you see in seals and dolphins and whales, animals that spend their entire lives beneath the surface. Somewhere in your deep evolutionary past, long before your ancestors ever crawled onto land, this switch was standard equipment, and it was never deleted. There is even more hidden in there. During a long dive, your spleen, an organ most people forget they even have, contracts. It squeezes out a hidden reserve of oxygen rich red blood cells like an emergency fuel tank opening a valve you never knew existed. The physiologist Erica Shagatai has spent years studying this exact response, and it hands divers a measurable jolt of extra oxygen at the precise moment they need it most. Your body was built for water. You just never had a reason to find out. And for some people, that machinery has been quietly upgrading itself for 1,000 years. Off the coasts of Indonesia and the Philippines lived the Bahau, the sea nomads. For over 1,000 years, they have lived on the ocean, in boats and stilt houses, diving for their food with nothing but a spear and a pair of hand carved wooden goggles. Some Bajau divers routinely stay underwater for minutes at a time, descending past 200 feet, working 8-hour shifts beneath the sea day after day. In 2018, geneticist Melissa Alardo traveled to Indonesia to find out how. Using an ultrasound machine right there on the beach, she measured the spleens of the Bahau. And she found something remarkable. Their spleens were around 50% larger than those of their land dwelling neighbors. A bigger spleen means a bigger reserve of oxygenated blood, which means more time underwater. But here was the twist that changed everything. Even the Bajau, who never dived, had the larger spleens. This was not the result of a lifetime of training. It was written into their DNA, a gene variant shaped by generations of natural selection, quietly favoring the divers who could stay under just a little bit longer. Working alongside geneticist Erasmus Nielsen, Alardo had found something genuinely rare, a living human population evolving in real time to belong to the sea. You are watching evolution choose the better diver, and it is still choosing. So that is your body's own limit. A few minutes for the trained, seconds for the rest of us. But what happens when you stop relying on the breath in your chest and start carrying your air with you? Everything changes. Strap on a scuba tank, and the rules break. The word scuba is short for self contained underwater breathing apparatus, which is just a fancy way of saying you bring your own air. A single tank lets a recreational diver stay under for roughly 45 minutes to an hour. Suddenly, minutes stretch into something as long as a lunch break. You are no longer holding your breath at all. You are simply breathing in a different room. But even that has a hidden ceiling, and strangely, it isn't about running out of air. Go deep enough, and the crushing pressure of the water forces gases into your blood in ways that turn dangerous. Rise too fast, and those gases fizz out of you like a shaken bottle of soda. Divers call it the bends, and it can cripple or kill. The deeper you go, the slower you must climb back, sometimes pausing for hours on the way up, just to let your body safely unwind. So, engineers found a way to cheat time itself. It is called saturation diving. Divers live inside a sealed, pressurized chamber, their bodies fully adjusted to the pressure of the deep. And instead of surfacing at the end of each day, they simply stay down there for days, for weeks at a time, working on oil rigs and shipwrecks far below the light. Their record for continuous life underwater is measured not in minutes and not in hours, but in weeks. Human beings quietly living at the bottom of the sea. And this is the strange place we have arrived. A creature that panics after 90 seconds in a swimming pool has learned to live on the ocean floor, not by growing gills, not by rebuilding its body, but by understanding, piece by piece, the machinery it already carried, the alarm that lies, the switch it forgot, the reflex older than its own legs. You carry an ocean's worth of history inside your chest. Every time you slip beneath the surface of a pool and feel your heartbeat slow, you are touching something ancient, a memory your body kept long after your mind forgot it was ever there. So the next time you are underwater and that pressure starts to build, remember what it truly is, not the end of your air, just an old, overcautious alarm standing guard over a machine far more capable than you were ever told. Take a breath, hold it. You have been carrying the sea this whole time.